Hello. Last time we did quadratic equations. This time we are ready to look at some other types of equations. This is kind of a catch-all section in the book. So we have three types of equations we're going to look at how to solve in this section. And we're just going to look at one technique for each type. Okay. The first other type of equation we're going to look at is what sometimes gets called polynomial equations. So that's just when we have an equation, so we have an equal sign in there somewhere, and we just have coefficients with different powers of x, and one side is equal to the other. In fact, quadratic equations fall into this category of polynomial equations, but we looked at several other techniques we could use with quadratic equations in particular. We're going to look at the technique that works for all types of polynomial equations, so any degree. And the idea here is that we're going to solve by factoring. So we did that with quadratic equations, but we also looked at completing the square in the quadratic formula. Okay, when we have other degrees, so maybe we got a degree 3 equation, cubic equation, degree 4, degree 5, degree 6, then really factoring is going to be our only option. Okay, so if we have some polynomial equation, we're going to solve by factoring. So let's take a look at one. Okay. So here's a short one. X to the 5th equals 9x to the 3rd. Okay, so we don't have anything too weird in here. We just have a couple of different powers of x. We have a coefficient on the x to the 3rd term of 9, coefficient on the x to the 5th term of 1. So we would call this a polynomial equation. So with these, we want to solve by factoring. So we want to get everything on one side and make it equal to 0. You'll recall from factoring quadratics. So here I'm going to subtract 9x to the 3rd from both sides. So leave me x to the 5th minus 9x to the 3rd equals 0. And now on the left side, we want to factor. Okay. This is not a trinomial, so we're limited on how we can factor. So really here, the first thing we always need to be looking for when we're factoring is to see if we have something in common. Okay. So here I see we have a common factor of x to the 3rd in both of these. So if we factor that out, x to the 3rd times x squared would give us x to the 5th, and x to the 3rd times negative 9 would give us negative 9x to the 3rd. Okay. If you look at the part inside the parentheses, x squared minus 9 will actually factor again. Okay, so that's the difference of two squares, so a plus b, a minus b. So here, takes x times x to get x squared. And then 3 times 3 is 9, so we need plus 3 and minus 3. And this still equals 0. Don't lose your equal sign. The equal sign is very, very important when you're working with an equation, so you need to keep up with where it goes at all times. Okay. So now, if you remember that property we had with quadratic equations, we had this property that said if we had a times b equals 0, then that means a is 0 or b is 0 or both. Okay. Well, the same thing's true in this case. Okay, it doesn't matter if you put another number in. If you're multiplying a bunch of numbers together and you get 0, then one of the numbers has to be 0, or a combination of them could be 0. At least one of the numbers has to be 0. Okay, so we're going to do the same thing that we did with quadratic equations. Here we're going to take each one of these factors, set it equal to 0. So I'm going to say x to the 3rd equals 0, x plus 3 equals 0, x minus 3 equals 0. We're going to solve all three of these. So here, we've got x to the 3rd. If we want to cancel that out, you can think about taking the cube root of both sides. And usually you won't have to write it down. You can just think about it here, and any root of 0 is 0. So here we get x equals 0. If you just see that that's 0, that's fine. There's a solution. On the second one, we can subtract 3 from both sides. We get x equals -3. That's a solution. And on the last one, we can add 3 to both sides, so we get x equals +3. That is a solution. Okay. If you check those work. 0 is really easy to check. 0 to the 5th power is 0. And then 0 to the 3rd power is 0. 9 times 0 is 0, so we get 0 on both sides. You can check -3 and +3 as well. Okay. And those all work, so we have 3 solutions here. Okay, let's look at another one of these polynomial equations. So remember, for all of these, we're going to get everything on one side and then try to factor. Okay? And that applies to quadratic equations as well. But sometimes you could, if you have a quadratic, you could complete the square or use a quadratic formula instead. But if it's not quadratic, then factoring's our only choice. So let's look at another one. Usually, there's actually a really big, ugly formula you can use to solve third-degree equations like this one. Okay, but it's much, much, much easier to just factor. So we'll do that. Okay, everything's already on one side here. We've got it equal to 0. So now we try to factor. We only have 2 terms, so really we're just looking for what we have in common. Get our greatest common factor. So I see 3 will go into both of these. And then our smallest power of x is 2, so x squared. So what will that leave us? 3x squared times x would give us 3x cubed. 3x squared times -2 would give us -6x squared. Okay. Check to see if there's anything else we could factor, and this is as factored as we can get. So now we take each factor and set it equal to 0. So here that's 3x squared equals 0. Okay, and x minus 2 equals 0. Okay, on the left side, if you see that that's going to be 0, that's fine. Okay, if not, if you want to write down all the steps we could take, we could say, well, we'll divide both sides by 3. 0 divided by 3 is still 0. We take the square root of both sides. We get x on the left, and the square root of 0 is plus or minus 0, which is just 0. But if you just see that's 0, that's fine. Okay, on the other one, we add 2 to both sides. We get x equals 2. Okay. So if you have one of these so-called polynomial equations, try to get everything on one side and then factor. Okay, the second type of equation we're going to look at solving in this section, what we call rational equations. Okay. Rational equations. So anytime you say rational, it means we're dealing with a fraction, a ratio. There is another name for a fraction. So this is not just that we have fractions involved, but that we have a variable in the denominator of a fraction. And we call that a rational equation. Okay? And our strategy for rational equations is we're going to multiply everything in the equation by the LCD. And that's the lowest common denominator. You'll remember it from adding and subtracting fractions, hopefully. Okay. So we're going to multiply everything in the equation by whatever the LCD is. Okay. And then one word of warning I'll go ahead and give you here is on these rational equations, excuse me, on these rational equations, when you get finished, you want to check your solutions, because it's possible that you do all the steps perfectly correct, but then some of the numbers you get as solutions don't work when we plug them back into the original equation. Okay, we call those extraneous solutions. So you want to check your solutions when you're get finished with a rational equation. Okay, really important. So let's take a look at one. Okay. So we said we call it a rational equation if we have a variable in a denominator. So here's x plus 4 over x plus 1, and this equals 3. Okay. So since we have that x plus 1, specifically that x down in the denominator, this is a rational equation. So we are going to multiply by our lowest common denominator. On this one, if you think about the denominator of the first term, it's just a 1. The same thing with 3, it's just a 1. So getting our least common denominator is really easy. We only have one denominator. Our only denominator is x plus 1. Okay, so here, we're going to multiply everything, every term, by x plus 1. So I'm going to make a note over here. Let's do it in a different color. So our LCD here is x plus 1. Okay, so we're going to multiply every term by x plus 1. So I'm going to multiply x by it. I'm going to leave some room. Then we're going to multiply 4 over x plus 1 by it. Leave some room. And then we're going to multiply the 3. We're going to multiply all those by x plus 1. So here's this times x plus 1. This is times x plus 1. And this is times x plus 1. If you practice with these, you don't necessarily have to write this step out. This step can get really long and tedious to write down, but when you're first starting out, you want to make sure you're keeping in your head what you're doing, so it's probably a good idea to write it all down. Okay? And the idea here when we do this is on some of the terms with denominators, we're going to get some stuff to cancel out. Okay? Here, our first product, we've got x times x plus 1. We got to do distributive property, so we get x times x is x squared. X times 1 is just x. Okay, but then look what happens on the second product we have. We've got x plus 1 in the denominator, and we're multiplying by x plus 1 on the top, so the x plus 1's cancel out. Okay, and it just leaves us with plus 4. That's really nice. Okay, and then on the other side, we have distributive property again. We end up with 3x plus 3. Okay. So now we don't have a rational equation anymore. What do we have? Let's look at this. Let me rewrite it more normally here without all the spaces. So what type of equation do we have now? Okay, now we have a quadratic equation. Okay. So we need to decide how we're going to attack this. Are we going to try and factor, or we're going to use quadratic formula? We're going to complete the square. If we're going to factor or use quadratic formula, we need to get all the terms on one side. Okay. So I only have the 1x squared term, but then I'm going to subtract 3x from both sides. So x minus 3x is negative 2x. And then I'm going to subtract 3 from both sides. So 4 minus 3, 1. That leaves us 0 on the right side. Okay. So here, we've got choices. We could try to factor. We could complete the square. We could do quadratic formula. Okay. Any of those are okay. Here, factoring is the fastest, if you see the factors. So we need factors of 1 that add together to give us negative 2. So what are those? Well, if we do negative 1 and negative 1, and that will multiply to give us positive 1. Negative 1 minus 1 is negative 2x. So there we go, we're factored. If you prefer quadratic formula, do quadratic formula, that's fine. You'll get the same thing. So here, if you notice, both of our factors are the same, so I'm just going to write it down one time. We get x minus 1 equals 0. And we add 1 to both sides, and we get a what we think is a solution. Okay, so is this a solution? X equals 1. Well, we got to go back to our original equation and check it. Okay. So what do we get if we plug this in. So if we plug in 1 here, we get 1. Okay. If we plug 1 in the second term, we'll get 4 over 1 plus 1, so that's 4 over 2, which is 2. And then on the other side, we get 3. So yeah, 1 plus 2 does equal 3. Okay, so this checks out. So this checks out. This is a solution. Okay. It's very important you check those, because sometimes when we multiply through by that LCD, we get extraneous solutions, and it's highly possible that we could take this number and plug it back into the original and it doesn't work. Okay. So make sure you check your solutions. Alright, so that one was a little easy because we only had one denominator. What if we have more than one denominator? We need to know how to do that. Okay, so let's look at one of those. Here we have 3 over x minus 2 over x minus 3 equals negative 12 over x squared minus 9. Oh boy, so 3 denominators this time. Okay. So if you have multiple denominators, the toughest part, the part that people struggle with most on these, is finding the LCD. Okay. And the LCD is not hard to find. Okay. But you do have to be a little careful. Okay. So let's look. We want to find our LCD over here, and then we're going to multiply through by that. Okay, so that's just kind of off to the side. So first, you want to make sure that all of your denominators are as factored as possible. Okay, so if we look at the first one, x, nothing to factor there. Second one, x minus 3, nothing to factor there. But if we look on the right side, x squared minus 9, that will factor. That's the difference of 2 squares. So that will turn into x plus 3 times x minus 3. Now, to get our LCD, all we have to do is just read off our denominators, okay? Because for it to be a common denominator, it has to have every factor represented in all of our denominators. So from the first one, we need a factor of x, right? So we got to put an x in our denominator. From the second one, we need an x minus 3, so times x minus 3. And then when we look at the last one, x plus 3 times x minus 3, we got to have an x plus 3. So we put an x plus 3 in our LCD. And then it says we got to have an x minus 3. Well, we've already got that one, and so we don't have to put it again. So this is our LCD. You know, it's kind of long, but we're going to multiply every part of our equation by our LCD. Okay, so we got 3 over x times the LCD minus 2 over x minus 3 times the LCD equals negative 12, and I'm going to write our denominator in factored form here, over x plus 3 times x minus 3, because it'll make it easier to see what cancels, times the LCD. Okay, so now we put our LCD in here, so times x minus 3 times x plus 3. Okay. And then same thing here, times x times, my pen's not working good today, times x minus 3 times x plus 3. And then same thing on the last one, times x minus 3 times x plus 3. Now we look to see what cancels. Okay, sorry, I almost ran out of room there. So what cancels? So in the first term, we've got an x and an x that cancels. In the second term, we have x minus 3 that cancels. And in the last term, ooh, look, we get x plus 3 cancels, and x minus 3 cancels. Okay, so now we look at what we have left. Okay, so we have 3 times x minus 3 times x plus 3. That's the most annoying one. Minus 2 times x plus 3. That one's not too bad. Equals, and the last one's really nice. What do we have? Just negative 12 times x, so negative 12x. Okay. Now we just start simplifying this stuff. Okay. So unfortunately, in this first term, we have FOIL method to do. So I'm going to do it first. So x times x is x squared. Okay, and then we have x times 3 is 3x on the outer terms. Negative 3 times x is negative 3x. So those will cancel there, and then we get negative 3 times 3 is negative 9. Okay. I'm going to do distributive property on the second term. So 2x times x is 2x squared. Negative 2x times 3 is negative 6x. And then there's nothing to do on the right side right now. Okay, we got one more distributive property to do on the left. So 3 times x squared, 3x squared. And then 3 times negative 9 is negative 27. Now we just need to look at what like terms we can combine. Okay, so if we can combine like terms, we've got x squared terms we can combine. So 3x squared minus 2x squared is x squared. And then we have minus 27. We don't have any like terms with it. Okay. And then here, I'm going to move and combine these at the same time. Okay, I'm going to add 12x to both sides. So negative 6x plus 12x is positive 6x. Okay. Alright, so how we're doing here, if we're gonna work with this, we probably want to put our terms in our normal order. Okay. And then we can either, it's quadratic, so we can either try to factor or complete the square or use quadratic formula. Okay. Here I'm going to look and see if we can factor. So we need factors of negative 27 that add up to positive 6. So I know 3 times 9 is 27. We want positive 6, so we'll do negative 3, positive 9. So not too bad. It paid off. It will factor. Get x minus 3, x plus 9. Set both of these equal to 0 and solve. Okay, so here we get x equals 3. Here we get x equals negative 9. But, what? We got to check them. Okay, we got to check these things. So we got 3 and negative 9 to check. We go all the way back. Okay. I see a problem right away. Okay, because if we try to plug in 3 here, we'll get 3 minus 3. That's 0. And you can't divide 2 by 0. Okay? Can't divide by 0. That's undefined. So 3 is not going to work. Okay? I can see that one. So this one, even though we did all the math right, it doesn't actually work. Okay? What about negative 9? If we do negative 9, well, 3 over negative 9 would be negative 1/3. Then we have 2 over negative 9 minus 3 is negative 12. So minus plus 2 over 12 is 1/6. And then that says that equals negative 12 over negative 9 squared. Okay, is 81. Okay, positive 81. 81 minus 9. 1 second here. 81 minus 9. Okay, I grabbed my calculator because I don't want to do all these fractions in my head, so that is over 72, and if you check it, that works because this side turns out to be negative 1/6, and if you reduce this other side, it's negative 1/6. So yeah, that does work. Okay, it's messy, but again, you can use a calculator and make quick work of it. Okay. So that one does work. Okay. So we have one solution here. Okay. Alright, video's getting kind of long, so I will do the last type of equation in part 2.